Hi everybody, we're working today on the distributive property, and I love to call this property the hopping prop, just so that you remember, like we did the commutative property, the little car that drives around, the associative property, the wrinkled up little parentheses that got in our suitcase. This is the distributive property, or I call it the hopping prop, where the numbers actually do hop like a rabbit. So I'm going to show you what it is, first of all, and then we're going to use it in some story problems. The math should work out for you, and you might say, well, Mrs. McKinley, why wouldn't I just use order of operation? Well, the reason I'm teaching it to you this way is because eventually we are going to put variables in, and you need to know how to hop the prop, if you will. So I'm going to show you 2 times, in parentheses, 10 plus 20. And I am going to demonstrate to you how the 2 can hop, and it becomes 2 times 10 plus 2 times 20. So first, let's just look at this side. If I just went through this and I said, okay, 10 plus 20 is 30, and then I multiply that times 2, just like normal order of operations, I'm going to get a 60. But what we are going to do is we're going to show how if you hop it, you will get the exact same answer. So you're going to do 2 times 10. So 2 times 10 I put in parentheses right here, and then I had the 2 hop all the way over. See the little feet I put there? That becomes 2 times 20. So if I combine the 2 times 10, I get a 20. Plus a 40, and then I get 60. So I can do it 2 ways. I can do 20 plus 40 equals 60, or I could do 2 times 30 equals 60. That's also a way to do that. So what we're doing is several paths to the same exact answer. Let's work backwards, and I have the number 120. What I'm going to do is I'm going to say, well, I want to count that as a 40 plus an 80. You can do that. 40 plus 80 is equal to 120. Well, I want to suck a 10 out of each of these numbers, so I'm going to suck that 10 out, and I am going to do 10 times 4 plus 8. Now, if I add 4 plus 8, I get 12. And then if I do 10 times 12, I'm still at 120. I could do hopping prop, the distributive property. I'm going to distribute the 10 through. 10 times 4 is 40. 10 times 8 equals 80, still equals 120, no matter how I factor it or pull things out of it or distribute it. We are going to take a look at the example in the book, so bear with me while we do a real world example. So if you have a car wash, let's say our class held a 2-day car wash, and the class washed 40 cars on the first day and 30 cars on the second day. The class charged $5 for each car. Let's look at the equations down here and decide which equation that represents the distributive property would be the correct equation. So I know that I had 40 plus 30 cars total, and that each one of those would be multiplied times 5 to get the correct answer. So if I look through here, this one doesn't have the times 5. This one only has the 40 times the 5. This one is subtraction, which doesn't make any sense at all. So D looks to me like you're adding the number of cars up, and then you're going to multiply that quantity times 5. Or you could do 5 times 40 plus 5 times 30, and you would get the same answer either way. Their solution has 2 methods to it. So they did 5 times 40 plus 30, which is 5 times 7, which is 350. Or when we do that hopping prop, like I showed you, 5 times 40 is what they made the first day, 5 times 30 is what they made the second day, and they still get 350. So this is just a simple matter of the distributive property. Would you please copy down the distributive property for your notebook right here? The words, the numbers, and the algebra. And I zoom in just a little bit. When you can see it well, pause and go ahead and write that into your notes. All right. What we are going to go through next is a little bit higher order to use the distributive property, and the distributive property can help a lot with mental math. So you can see here the 2 times the 50 plus 6 is 2 times 50 plus 2 plus 6. You get 100 plus 12 is 112. Notice that it's easy to multiply the 2 times the 50. You may have a number like 6 times 87. You could write 87 differently and say 6 times 90 minus 3, because notice 90 minus 3 is the same as 87. We haven't changed the amount in parentheses, we've just changed the way we've gotten it. So if you do 6 times 90, that's easy, 540, because you know 6 times 9 is 54. And then you do 6 times 3 is 18, so then you take away 18 from it to equal 522. Now you say, why wouldn't I just multiply this out? This distributive property enabled us to creatively change the quantity or the number 87 into a 90 minus 3. It just made it easier to do mental math to figure this question out. If you would like to write down this example too, might be a great idea. I'll try to get it in focus a little more. It is in your book if you need it, but you can pause that and really circle this part where they've rearranged 90 minus 7 and 87 minus 3, and I'll even do this, that they just changed it. They didn't change the amount, they just changed how it was written. So this one I thought was really interesting. We've got the Hubble telescope. It orbited Earth at the rate of 4.78 miles per second. How far did the telescope travel in just 3 seconds? So here's what they did. They used the formula distance equals rate times time. And we know that distance is 4.78 times 3. Yes, I know that you could just simply write that out and do the arithmetic, but what they chose to do is write 5 minus 0.22. That's still equal to 4.78. They just took 0.22 away from it, or 22 hundredths away from it, excuse me, and then multiplied all of that times 3, which 5 times 3 is 15, and then 22 hundredths 3 times is 0.66. So if I subtract those two, I should get 14.34. So they simply rewrote the number 4.78 and they expressed it as 5 minus 0.22. So once they subtracted, they got 14.34 miles in 3 seconds, which is absolutely amazing. What you are going to need to know how to do is identify the distributive property. You are going to need to be able to use it as the hop. Remember how it hopped to the two different numbers and you added them together? Or add what's inside the parentheses. It doesn't always work to do that because sometimes they put a pesky little variable in there. So if you have 3 times x plus 4, you need to be able to do, let me write that in your notes. This is a little bit more of an extension for you guys. 3 times x plus 4, and I'll put the other notes up in just a moment. So if I do 3x plus 4, and if I use the hopping prop, you can't add an x plus 4 because we don't know what x is. We don't know if it's a 2 or 100 or a billion. So this would be equal to 3x's plus whatever 3 times 4 is, which is 12. That's how you figure out what to do if you have a variable in there. Please come up if you have any questions at all, and good luck on your assignment today.